Hello friends, this is Asta Sharma from MTech IT 2K21 batch. We have paper of internal one of data science. Let's start our discussion on this paper. Now firstly we have to understand what is decision tree. A decision tree is a structure that include a root node, branches and a leaf node. Each internal node denotes a test on an attributes. Each branch denotes the outcome of a test and each leaf node holds a class level. The topmost node in the tree is the root node. The following decision tree is for the concept by computer that indicates whatever customer at a company is likely to buy a computer or not. Each internal node represents a test on an attribute. Each leaf node represents a class. Now, and what is entropy? Entropy is used to measure the impurity of a data science. More the entropy, less pure will be the attribute. We use the given formula to calculate entropy of any required data. So this is the formula. Here pi equals to probability of randomly selected an example in class I. Information gain is defined as the pattern observed in the data set and reduction in the entropy. Mathematically, information gain can be expressed as information gain equals to entropy of parent node minus entropy of child node. Again, if the information gain is high, the entropy will be low and vice versa. Let's start our discussion on this paper. We have the question number 1. Find the splitting criteria for this tuple using computation of information gain of each attribute. We have given this table, and through this table we have to find out the decision tree by information gain. So the solution is splitting criteria using information gain. Information gain info of D equals to this. By applying the information gain formula, we have this. We got this, and the solution and the answer of this is 0.940 bits, and information age of D equals to this is by applying formula, and we got the answer is 0.694 bits, and the information gain is 0.940 minus 0.694 equals to 0.246 bits. Splitting criteria using information gain. Similarly, gain income equals to 0.029, gain credit rating equals to 0.151, gain student equals to 0.048. As the attribute, age has gained a higher info gain value, so age will be the best splitting attribute. This decision tree will look like this. This is the decision tree. And here it is very clear that the sub attribute middle aged has all the values of class as yes, which means it has the lowest entropy, that is it has the attribute with high purity. Splitting criteria is using information gain again. The data set with age equals to youth will look like this. We see this table here. If the attribute student has the value yes, then we get the value of class equals to yes, which means the next splitting attribute here will be student. If student equals to yes, class equals to yes, else class equals to no. The data set with age equals to senior will look like this. This is the table. Here if the attribute credit rating has the value fair, then we get the value of class equals to yes, which means the next splitting attribute here will be credit rating. If credit rating equals to fair, class equals to yes, else class equals to no. Formula used to find out the Gini index of any attribute is given below. This is the formula. Gini age equals to 0.342, Gini income equals to 0.449, Gini student equals to 0.367, Gini credit rating equals to 0.428. The value generated are totally different from the value of each attribute that we calculate using information gain. Here the attribute with the lowest Gini index will be our splitting criteria, that is age will be the root node here. Here we can see the root node is age. The value of attribute age is either youth, middle-aged or senior. If age equals to middle-aged, we get the class value as yes. Otherwise, we will consider another splitting attribute. In case of youth, Guinea income equals to 0.453, Guinea student equals to 0.289, Guinea credit rating equals to 0.368, 365. Hence, the next splitting attribute will be student if student equals to yes. The value of class is also yes, and if student equals to no, the class value we get is also no. And this is the table which, with the help of this table, we can find out our decision tree. The value of attribute uh, age is either youth, middle age. Okay, this is okay. Solution of question number 3, decision tree and rules. If age equals to youth, if student equals to yes, bias computer equals to yes, else bias computer equals to no. Else if age equals to senior, if credit rating equals to fair, bias computer equals to yes, else bias computer equals to no, else bias computer equals to yes. Here we are comparing that age equals to senior, if otherwise we cannot, and otherwise bias computer equals to no. So this is the decision tree we obtained at the last with the help of Gini index and information gain. um, Thank you so much.